My name is Farah Wahida.
My name is Tracy.
I'm Lim Zu Jian.
We are from
Group B7.
We would like to present our last experiment entitled
Sedimentation Studies Apparatus.
What is sedimentation? Sedimentation is a physical process that brings the heavy materials to the bottom of the water to form a solid layer by gravity. In this experiment, we are using top bench sedimentation studies apparatus, which contains of 5-cylinder column of 1 meter that attached to the vertical back panel which emanated from the back. Ladies and gentlemen, in this experiment contains 2 parts, which the objective for the first part is to study the effect of different initial height and also concentration on a settling rate. Meanwhile, for the second part is to study the effect of different volume of flocculant used on a settling rate.
At the beginning of the batch sedimentation process, the solids are uniformly distributed in the liquid column. After a short while, the solids have settled and give a clear liquid region, which is zone A, and zone D for settled solids. Layers A, B, C, D are formed where the settling process continues, and the depth of these columns changes accordingly. Meanwhile, the gradual accumulation of solid puts stress on the material at the bottom, which compress zone D. The compression breaks down the structure of flocks or aggregates, and the liquid is expelled to the upper region. The settling process is stopped when the weight of the solid is balanced by the compressive strength of the flocks. This entire process is called sedimentation.
In experiment 6, there are 2 parts of the experiment, part A and part B. Before conducting the experiment in part A, we are required to check so that all 5 cylinders are being cleaned and emptied out. Next, we will prepare 5 different solutions with 5 different concentrations and 5 different solution height. The specifications of those 5 solutions are being shown to you right now. After that, we will connect the power cord to the power source to turn on the back panel illumination. Then, all 5 solutions will be poured into 5 cylinders labeled C1, C2, C3, C4, and C5. The solutions are being mixed well until a uniform distribution is achieved. Then, all 5 solutions containing in the cylinders will be put on top of the back panel illumination. T-note, which is the initial time, is recorded. For 5 minutes time interval, the height of the clear liquid intersurface will be recorded. This will be continued until settling stops. Then, the final time, TF, will be recorded. The final height of the clear liquid intersurface will also be recorded for all 5 of the cylinders. Last but not least, a graph of the height of clear liquid interface versus settling time is plotted.
For experiment B, the experimental procedure is as follows. The first one, you need to empty the cylinder by holding the top and the middle section of the cylinder and pull it back from the back panel. And the second one, you need to prepare the flocculant solution by mixing 2 grams of aluminum oxide and 100 ml of water. The third one, you need to prepare 5 different sets of corn flour solutions. The composition is as follows. Next one, you need to remove the cylinder cover and pour the solution into it. After that, you need to plug the power cord onto the power socket to turn on the back panel illuminator. Then, you must turn all the solution until it homogeneously mixes. After that, you need to take the initial time taken. For 5 minutes interval, you need to take the reading of clear liquid interface until the sedimentation stops. And then you need to record the final time and also the final height. Run this experiment for 1 hour. After that, you need to plot the
first experiment, the effect of different initial heights and concentration on the setting rate is studied. The graph of clear liquid interface height versus time for 50 gram at Z0 equals to 90 cm and 60 cm is showing a decreasing trend, which is in the same case for 100 gram at Z0 equals to 90 cm, 60 cm and 30 cm. On the other hand, the graph of clear liquid interface height versus time for Z0 equals to 90 cm at both 50 gram and 100 gram is also showing a decreasing trend, which is in the same case for Z0 equals to 60 cm for both 50 gram and 100 gram. In experiment 2, the effect of different volume of flocculants on the saturation rate is being studied. The graph of clear liquid interface height versus time showing the decreasing trend for both 50 gram and 100 gram. At the same time, the graph of clear liquid interface height versus time for Z0 equals to 90 cm and 60 cm with different volume of flocculant is showing decreasing trend as well.
As mentioned previously, experiment 6, there are two parts of the experiment, which is part A and part B. In part A of the experiment, we aim to study the effects of initial height and concentration towards settling rate. As we can see from all the graphs, the higher the gradient, the higher the settling rate. From the previous graph, we can also see that the lower the initial height, the higher the settling rate. This is because the lower the initial height, the shorter it is for the distance between the solid particles and the bottom of the cylinder. Therefore, with the help of gravitational pull, it takes a shorter amount of time for the solids to travel down and settle down to the bottom of the cylinder. However, in graph 2, we see that the result is slightly opposite to what our theory has been saying. This may be due to certain errors that have occurred during the conducting of this experiment. Next, we can also see from graph 3 and 4 that the higher the concentration of the solution, the lower it is for the settling rate. This is because the higher the concentration of the solution, the bigger it is for the intermolecular force between the molecules in the particles. Therefore, the more hindrance it is for the solid particles to travel down to the bottom of the cylinder. With the help of gravitational pull, there will took a longer time for the solid particles to travel downwards to the bottom of the cylinder.
In this experiment, we found about 3 different types of error, which are parallax error, experimental error, and also human error. For the parallax error, in which the error while taking and observing the result, which may cause slightly different from the original one. So we need to make sure our eyes is perpendicular. We can put the white cover behind the cylinder to get a clearer view. Second one is experimental error. Fluctuating is said to be easily settled before we mix it with the cornflour solution. By here, we need to make sure we fluctuating agent vigorously while we mix it with the cornflour solution. And the third one is human error. Human error in which the inconsistency of the time interval while taking the clear water interface height. By here, we need to make sure that we repeat the experiment about 2 or 3 times to get the average value.
There are 5 safety precautions that we need to take note in the laboratory. First, we should always observe the safety precautions in the laboratory. Second, we should always wear protective clothing, helmets, goggles, and shoes throughout the laboratory session. Third, we should always run the experiment after fully understanding all the equipment and procedures. Fourth, we should always plug in the cables into appropriate sockets before switching on the main switch on the control panel. Inspect all the cables for leakage and replace if necessary. Fifth, we should always inspect the units such as tubings and fittings periodically for leakage and worn out. Leakage may cause damage caused by the corrosive chemicals in the long run.
In conclusion, we are able to study the effect of the initial height, the concentration of the solution, as well as the volume of the flocculant towards setting rate. We are able to conclude that the lower the initial height, the shorter the distance between the solid particles and the lower end of the cylinder. With the short distance, it will enable the traveling period of the solid particles down towards the bottom of the cylinder to be shorter. Next, we are also able to conclude that the higher amount of concentration in the solution, the lower the setting rate. This is because the higher amount of concentration in the solution, the more intermolecular force there is. Hence, more hindrance will be caused for the solid particles to travel downwards to the bottom of the cylinder. Hence, it will take a longer time and lowers the setting rate. Last but not least, we are able to conclude that the higher the volume of the flocculant, more particles will be come together. As more particles come together, there is an increase in the weight density. As solid density increases, with the help of the gravitational pull, the solid will be able to travel downwards and settle to the bottom of the cylinder at quicker times, hence increasing